With Madonna.
I know one.
Okay. They're muttering about songs and singers and things. I don't know why. They're stalling. Okay. But we're going to continue because now we have 4 minutes. You killed 30 seconds. Section 13.6. Come back to me. So another unit of solution concentration is molarity. And this is the one that is used most frequently in chemistry. Molarity is defined as number of moles of solute per liter of solution. So the mass percent was grams per 100 grams. Molarity is moles per liter. And it has to be liters. It can't be milliliters. And it has to be moles. It can't be millimoles. Can't be grams. It's moles per liter, always. And again, this is liters of solution, not liters of solvent. So when we make a solution of a specified molarity, we generally have a goal in mind. Okay, I want to make 1 molar or such and such. You're going to put the solute in, and you're going to add enough of the solvent so that you come up to that volume that you want. And so you've got the whole volume of solution. We never look at, well, how many liters of water? No, it's liters of solution. So here's an example. So you would have to figure out what mass of solute you need, because the balance doesn't weigh in moles. So you would have to convert the number of moles you need into grams so that you could weigh it out. And then you'd add your solute, and then you're going to add some water. You're actually going to pause here before you fill it up all the way, and you're going to dissolve it first, and then you're going to fill it up. This is a volumetric flask, and it's got a line marked on the neck. And these are more accurate for measuring volume because a small difference in volume will make a large difference in the height of the liquid. If you were to do this in a beaker and you add, 5 milliliters more of water, you might not even perceive that the level went up. But in this skinny-necked flask, if you add 5 milliliters of water, you're going to see a big difference. So it's a more accurate piece of glassware for measuring volumes. So let's do this. Let's calculate the molarity of a solution made by putting 55.8 grams of sodium nitrate into a beaker and diluting to 2.5 liters. So calculate the molarity. Well, what is molarity? It's moles per liter. So molarity is abbreviated with a capital M, and so that M that I just drew at the top there, is that a capital M or a lowercase m? That's a capital one. How about this one?
Lowercase?
That one's lowercase. It's relative, right? Because usually when we write M's, they kind of aren't necessarily beautifully perfectly round on top or perfectly square, right? So it gets sloppy. So what a lot of people do is, if it's a capital M, you underline it, because you don't want it to look like a lowercase m, which is an abbreviation for meters. Lowercase m is not the abbreviation for mole. MOL is the abbreviation for mole. I see it in people's work. You put M. M is meter. Capital M is moles per liter. Molarity. And so I'm writing with the eraser. That doesn't work very well. So molarity is moles per liter. So we need to find the moles of sodium nitrate and the liters of solution. Well, they gave us the liters of solution, so we put that in, 2.50 liters. But how do we find the moles? Well, this is one of those really important calculations we do in chemistry, converting between moles and liter, molar mass. And it just comes back over and over and over again. So sodium is 22.99, and nitrogen's 14.01, and 3 times oxygen is 16. And that comes out to be 22.99 plus 14.01 plus 3 times 16, you get 85. Some of those crazy ones that comes out to an even number, and you're like, what? It's grams per mole. So we take our mass, and we're going to multiply by moles and divide by grams, right? Dimensional analysis. Well, 1 mole weighs 85.00 grams. So we're going to take our 55.8 and divide by 85. 0.6565. I'm going to put an extra one in there. Moles. That's what goes in the numerator. 0.6565 moles. 0.6565 divided by 2.5. That's cool. Calculator says 0.2626. Numbers are fun. But we have to round that off. 0.263 molar, capital M. Capital M means moles per liter.